In the fields ranging from cognitive psychology to mass communication to advertising, researchers in the past 60 years have always been trying to understand the influence of the kind of data in messages on readers' beliefs and attitudes. These data have been labeled as evidence. When you're making a claim or an argument, you can build credibility by supporting it with evidence. If there is anecdotal evidence on one end, which is your examples, personal experiences, a set of isolated observations, or you have statistical evidence on the other end, which is a summary of the numerical data of a large sample size, it's usually the statistical evidence that comes out to be more persuasive. The importance and influence of statistics can hardly be overemphasized. But when used in certain marketing contexts, there are some important things about statistics that you should know because numbers can also be manipulated. And suppose there's two sacks of oranges, sack A and sack B. Sack A has a mixture of oranges, small, medium, and large. Sack B also contains a similar mix, but the oranges at the top of the sack happen to be larger and shinier. You pick up 5 oranges from sack A and 5 oranges from the top of sack B, and you conclude that sack B has better oranges as compared to sack A. This is what is usually known as a sample bias. Your sample came from a biased part of the sack. Sample bias occurs when the method of selecting samples systematically favors certain outcomes, leading to conclusions that do not accurately represent the full population. A good way would be to get oranges from all different parts of the sack, one from the middle, one from the end, one from the top, or maybe give a good shake to the entire sack and then take out 5 oranges. This is also what is known as random sampling. So if you read in the newspaper that 60% of Delhiites are sleeping late, usually after 11 p.m., you need to question whether that sample is truly representative of the entire proportion of Delhiites. Maybe they only interviewed young adults or people who are in their 20s or early 30s. There is a well-known saying in statistics that if your head is in the oven, if your feet are in the freezer, then on an average, you're okay. This saying highlights the limitation of using averages and how it can fail to present the true nature of a situation. For example, if in a classroom one student scores 100% on a test and 9 other students score 0%, the average score would be 10%. This gives the impression of a low performing class but fails to highlight the outstanding performance of the one student. Let's say in a healthcare context, a hospital boasts of a recovery time of 3 days, but this may conceal the fact that some patients recover on the same day while others take weeks or months to recover. In the first example, if the range was mentioned, we could have known that there was a student who scored 100%. There are other technical nuances like the skewness, the normality, the presence of outliers or extreme values, median, mode. All of these different things paint a true picture. Averages by themselves are usually not very meaningful. Just because two things happen together does not mean that one causes the other. Just imagine a study found that when ice cream sales go up, the number of people who drown also goes up. And there's a headline that screams, "Ice cream causes drowning." But the real cause is a hidden factor, the weather. When it's hot, people buy ice cream and more people go swimming. The heat causes both things. Ice cream does not cause drowning. Interestingly, to say that one factor alone causes something to happen is still questionable. Let's take an established fact that smoking causes lung cancer. Smoking is not a sufficient cause, neither it is a necessary cause for lung cancer. People who do not smoke also get lung cancer. It depends upon your age, your genetics, the frequency of your smoking, air pollution. But it's safe to say that smoking significantly promotes lung cancer. So every time you come across a product that says it'll boost your memory or revitalize your body, be very wary of that causal implication. Graphs and charts are meant to quickly help us understand patterns in data, but they can also be manipulated to exaggerate differences. Consider a chart comparing the growth of two companies, company A and company B. Company A's line appears to shoot upward while company B's looks almost flat, giving the impression that company A is vastly outperforming company B. However, this effect is created by the y-axis. Instead of starting at 0, it begins at 90. By truncating the y-axis, small differences in growth are visually magnified. In reality, both companies grew by only a few percentage points, but the zoomed in scale makes the difference appear much larger than it truly is. Statistics can be misleading when people only show you the parts of their research that they want to show. Imagine a researcher tests a focus boosting supplement. They try it on 20 people and measure focus in 5 different ways. 4 tests show no effect. 1 test shows a small improvement. If the researcher only reports that one positive result and ignores the others, it looks like the supplement works, even though most of the data says it doesn't. The numbers aren't fake. What's misleading is what's being shown and what's being ignored. One way to check the validity of the statistics is to find the source of the data. Who conducted the study and who funded it? How rigorous was the statistical analysis? Was it pre-registered? What did the researchers have to gain out of it? Are there any conflicts of interest? In essence, be more critical, especially when it comes to numbers. Read competing evidences, ask questions, and then decide.